let's review pyramids. All right, so pyramids, first of all, so prisms have two bases and cylinders have two bases, but pyramids have only one base. They also have a vertex, right? So right here, let's actually just point out the base. This is, let me write in something besides blue since the pyramid is already blue. All right, so right here is the base of the pyramid, and opposite the base is a vertex. And all a vertex is just a point, right? So has only one base. Let's make that look a little neater. And it has a vertex opposite the base. And the sides, so the sides of a prism are rectangles. The sides of the lateral sides of a pyramid are triangles. So if you have any shape that's not a triangle, that is the base. So the volume of a pyramid is 1/3 the product of the base area times the height of the pyramid. Right? So with prism, it's just the product of the base area times the height of the pyramid, times the height of the prism. With pyramids, we're also going to multiply that by 1/3. Right? And this formula can be used with any type of pyramid. So the volume of a pyramid is 1/3 the area of the base times the height. And when we say height, we're referring to the height of the pyramid, big H, which is the distance between, oh, right then there. The big H is the distance between the base and the opposite vertex. And you may be wondering why the 1/3. So I try to demonstrate this in class with a three-dimensional model, but I think this two-dimensional model will get the point across. All right, so this is, well, I have a pyramid here, and this pyramid is, the height here is half the height of the rectangular prism. This rectangular prism happens to be a special rectangular prism. It's a cube. So H here is half of S, right? So, and this is a cube, so all of the sides are S, but the height of this prism is S. And the height of the pyramid is only H, and H is half of S. Now, I can fit one pyramid at the bottom. I can turn this around, turn 180 degrees, and we can fit a pyramid up top. Those two are kind of easy to see. And I don't think the side ones are too bad. Right, so it's not oriented exactly the right direction, as you can see, but we could fit a pyramid on this side, and we can flip this around 180 degrees and fit a pyramid off to this side as well. Seems to fit in. I don't know if they both don't fit in right because they're not oriented right, but if I could turn this, you'd see it fits in that little corner there. What's maybe a little harder to see, right? So we have two, one on top, one on the bottom, one on each of the sides, and then we can also fit one in at the front. So this one's a little hard for me to turn it so you could see it, but here if I outline. So if we put the base of the pyramid right here in front, right, it would go to that point there. And likewise, if we put the base in the back, it would also go right to that point. So here we can fit 6 pyramids. Right, so can fit 6 pyramids, and that's we'll specify square pyramids. in the cube, where h is half of s. Right, so it's half as big. If h equaled s, then we could fit only half as many cubes, or excuse me, pyramids in the cube. So then we could fit 3 pyramids in the cube. And you literally could, if you have 2 pyramids that have one pyramid and one prism, and they both have the exact same base and they're the exact same height, you can the prism, right? So the volume of a pyramid is the area of the base times the height of the pyramid, and the height of the pyramid is the distance from the vertex to the base, right? And then times a third. Times a third are divided by 3. They're the exact same thing. Right? Because we don't have 2 bases, and because our sides are triangles, right, the volume of a pyramid is only 1/3 the volume of a prism. Right? But let's find the volume of some pyramids together. Right? So here's the first one. This is a square pyramid. Right? And so we know a square, all the sides are the same. So every one of them is 12 inches, all 4 of them. Right? So to find the area of the base, we're just going to take 12 and square it, or multiply 12 times 12. So the area of the base is 144 inches squared. The height of the pyramid is the distance from the base to the vertex, and so that would be the height. And so the volume of this pyramid is 1/3 times 144 times 10. Now, you can just multiply the numbers across, right? And I just look to see if either of them are divisible by 3. How you can tell if a number is divisible by 3 is if you add up the digits and the sum is divisible by 3, so is the number. So for instance, 4 plus 4 plus 1 is 9. 9 is divisible by 3, so 144 is divisible by 3. All right, so if we divide 144 by 3, that would be 4. We'd have 2 leftovers. 3 goes into 24 8 times. So the volume of the pyramid is just 48 times 10, or 480 inches cubed. All right, so you're just multiplying the 3 numbers across. And it doesn't matter which order you multiply numbers in. Here's the next pyramid. This one is a triangular pyramid. Specifically, this is an oblique triangular pyramid. The first one was not just a square pyramid, but a square right pyramid. Now, you may think, what's the difference between right pyramids and oblique pyramids? So right pyramids, I'll write that down here. This is a right square pyramid. So for a right pyramid, the vertex is right over the center of the base. On an oblique, the vertex is not at the center. So the only way you're going to have a triangular pyramid that's right is if the base is either an isosceles or equilateral right triangle. All right, so we want, isosceles or equilateral triangle. This one is a right triangle, which is good because it makes it easy to find the area of the base. So we want to find the volume of the triangular pyramid, and this specifically is a right triangular pyramid, which means the base is a right triangle. So it's an oblique right triangle pyramid. All right, but we won't mix up too many words. So it's an oblique triangular pyramid whose base is a right triangle. All right, so but the type of base has nothing to do with whether or not it's oblique or right. But it does mean it's easy to calculate out the area of the base. So to find the area of the base, remember that when we're calculating out area, base has to be perpendicular to height. Right? And so we can see the 6 inches and the 8 inches are perpendicular to one another because they meet at right angles. So therefore, the area of the triangle, we take 1/2 times 6 times 8. So Half of 6 is 3. 3 times 8 is 24 inches squared. That's the area of the base. The height of the pyramid is just the distance from the base to the vertex. So the height is 14 inches. And so the volume is 1/3 times 24 times 14. Well, 1/3 of 24 is 8, and 8 times 14, so 8 times 10 is 80. 8 times 4 is 32, so 80 plus 32 is 112 inches cubed. Right? And there we go. We found the volume of these two. Right? So it's not too bad, right? Just like find the volume of the prism, just divide by 3 or multiply by 1/3. All right, so if we don't know the height of the pyramid, sometimes we're not given the height of the pyramid, we will have to use Pythagorean theorem to find it. We can create a right triangle from the top to point O to point N. Right? So the height is always perpendicular to the base. So regardless of what kind of pyramid this is, whether it's right or oblique, there is a right triangle that's formed from the height, right, to the edge. And this is actually called the slant height. Right? So this height inside the pyramid is just called the height or the altitude. This is called the slant height. The height is used for volume. The slant height is used for surface area. Both of them, if we're missing either one of them and we need either one of them, so here we're given the slant height, we don't need it, but we're given it. But we're not given the height. So we can use the slant height to find the height, right? Because there's always going to be this relationship that the height squared, right, plus, and this is just the distance to the edge, from a point under the vertex, I won't write all that in because it gets kind of long, equals the slant height squared. All right. So now I already have this calculated out. All right. So the length of OM is half the length of the side of the square base, and the height of the pyramid is a line perpendicular from the base to the vertex. So this would always be the point underneath the vertex will always be half of the base if it's a square. Right? And this is a square pyramid, so its base is a square. Right? So now we can find the height of the pyramid by taking the slant height squared and setting that equal to the distance to edge squared plus the height squared. Right, so that's 20 squared equals 12 squared plus h squared. 20 squared is 400. 12 squared is 144. And if we subtract 144 from both sides, we get 256. And then take just the positive square root because this is measurement. So the height of the pyramid is 16. Right, so now we know the height. We can find the base. It's a square. Right? The sides are all 24 centimeters. So the area of the base is 24 squared. And that means the area of the base is 576, this is centimeters squared. So to find the volume, let's see, I think I need a little bit more space. Right, so the volume is going to be 1/3 times 576, and then this is big H here, height of the pyramid, times 16. All right, so let's see if 576 is divisible by 3. 6 plus 7, 13, plus 5 is 18, yep. All right, and if it's not, then the decimal's okay. All right, so 576 divided by 3, all right, so 5 divided by 3 is 1, I got 2 leftovers. 27 divided by 3 is 9, no leftovers. 6 divided by 3 is 2. So I multiplied by 3, but I wrote it in anyway. There's no more 1/3 once I multiply by a third. 192 times 16. And I think I will use a calculator on this one, so I don't have to do that one in my head and risk losing any decimals there. So that would be 3,072 centimeters cubed. And there we go. All right, so not too bad, right? This one's done. Let's do some more. And we may have to solve for the missing height. All right, so here we want to find the volume of the square pyramid. We're given that the side length is 10 centimeters. All right, so that means that the distance from the center to the edge is going to be half that because it's a square. Right? And this one is going to be a right pyramid, specifically a right square pyramid. When your base is a square, right, that's a very regular figure, meaning all sides and angles are congruent. The center, the apex here is going to be directly over the center of the base. So to find the height, we're going to take here's the slant. Hopefully you can see that's the slant there. The slant squared. And set that equal to the distance to the center squared. Plus the height squared. All right, so the slant height is 13. The distance to the center is 5. And the height is what we're looking for. So 13 squared is 169 equals 25 plus h squared. Subtract 25 from both sides. 144 is the height squared. We want the height. Just take the positive square root. I mean, there's two answers, but we only want positive because it's a distance. So the height is 12. Right? So the area of the base, nice and easy. It's a square. So the area of the base is going to be 10 squared, or 100 centimeters squared. And then we'll just use the area of the base and the height of the pyramid to find the volume. So the volume is 1/3 times 100 times 12. Now, 100 is not easily divisible by 3, right? Because 1 plus 0 is 1. Right? 1's not divisible by 3, but 12 is. So 12 divided by 3 is 4, and 4 times 100 makes that 400 centimeters cubed. And there we go. That's all there is. All right, so now let's find the height and volume on this one. This one is a rectangular pyramid, and specifically it's a rectangular oblique pyramid. Rectangular pyramids don't have to be oblique, but this one is clearly, the apex, the vertex, is clearly not directly over the center. Right? So this one is not. Right? And I think one of my numbers, we've got the slant squared. 2 centimeters is this distance here, and I think we're missing one of our numbers, and that if I move the screen down, I'll find it. There it is. All right, so we'll just put the screen like that. All right, so if the distance from the point underneath the vertex to the edge is 2, and the whole side is 10, that makes this distance here equal 8 centimeters. Right? That's why they had to give us the 2. They either had to tell us that that's 8 centimeters, or tell us how much of that side is not the part of the right triangle there. So 2 centimeters is not in the right triangle, and the whole side is 10 centimeters. 8 centimeters is in the right triangle. So again, we'll find the height. So we're given the slant. That's right here. and we're missing the height. All right, so just like before, slant squared is equal to, I'm going to move this down a little bit, distance to the edge squared plus the height squared. All right, so the slant is 10. The distance from the edge to that point underneath the vertex is 8. So we got 10 squared equals 8 squared plus, and we're looking for the height squared. So 10 squared is 100, 8 squared is 64. Oops. If we subtract 64 from both sides, we have 36 is height squared, and then we're going to take the square root, but we only want the positive. Right? So 6 is the height. So now we have the height. All we need now is the area of the base, and then we can find the volume. Right? So this is a rectangle. The area of the base is going to be the one side times the other. And I don't know if you can see it, but I can see it except on the smartboard. So I think it's just the smartboard that's not quite oriented right. So there's one side, 5 centimeters, and there's the other side. All right? And we know to find the area of a rectangle, we just multiply the two different side measures, the two consecutive sides. So the area of the base, is 10 times 5. That's just writing weird. Right, and so the base area is 50 centimeters squared. We have the height, we have the area of the base. Now all we want to do is find the volume. Right, so the volume is 1/3 times 50. And then the height is 6. So of course 50 is not divisible by 3, but 6 is. 1/3 of 6 is 2, and 2 times 50 makes this 100 centimeters cubed. And there we go. I think this might be my last pyramid problem. And if it is, and that'll be the end of this video. And in the next video, we'll see cones. Let's see. And yep. So I'm gonna stop this video, and in the next video, we'll take a look at cones. Thanks for watching. Bye for now.